Hello, I'm Roman, and welcome back to a series of videos, Neural Networks from Scratch in Golang, where we're using this book called Neural Networks from Scratch in Python, but we write in everything with a Golang. I want to remind that recently I opened a Discord channel for both of my channels, and yes, I have two YouTube channels, this one and well, I call it main one. That's basically just the first channel that I created with Talking Head videos about tech industry, software engineering, like explain series, and all of these things. So don't forget to join. You'll find all the links into the description, in the channel information, and in the pinned comment, so you won't lose it. Today, well, not today. I'm still on the chapter 18 model object, but I'm very close to the end and I need to implement a couple of things. The first thing is this hack, and on the previous video I actually came up with the idea. I want to try how I can implement this and not mess with the model's train code. So the model will be uh, abstract, and I have this to-do list that there are some things I need to fix before we can go to using the real data set. And today actually have very few time, well, very little time for the recording. So I don't know, maybe this video will be even 20 minutes. But it's Monday. I have really many things to do, but I don't want to miss recording of this series. So what I can do, I won't do anything big, but I can do something small and, meaningful and completed. And one of the things I've been thinking, instead of checking, I need to change one thing. Sorry, this one. And there is one thing I can actually fix, and I have this, which one? Binary cross entropy. I think the binary cross entropy I already fixed. Oh no. So I have three things to fix. I have the binary cross entropy loss, I have the mean squared error loss, and I have, well, mean absolute error loss and mean square error loss. And the thing is that before I implement it in a way, it assumes that the number of, target, how it's called, the array of the target values contains number of the samples with one output. And that's not, that works only if I'm using it for the binary. I think the binary regression model, but is where it used. Oh, it used in the regression model, not the binary. It just used in the regression model that tries to predict the output value. And if you can take a look, the last layer contains one output. So the code that I wrote here will work only for, but is it? It will assume that predictions has only one value for the sample. And what I need to fix, I can actually fix it. If we take a look at the original code of the mean squared error, I think this one. If I take a look at the original code, it calculates the mean value. For example, if we're talking about the mean squared error, I don't have the mean, right? Because in the end, it should return, the forward method, it should return array of the float values. And if you take a look here, we have the result, and it just calculates the squared difference between the item, between the prediction and the targets. But if I will have, and since it's the calculation of the errors, I need to have one value for each sample. So what I need to do, I need to change it to calculate the average, because currently it assumes it's just a one-dimensional array, and the result should contain average of the squared differences across whole row. So this is, I will try to fix it right now. And yeah, I will try to fix it for the mean squared error loss and the mean absolute error loss, and probably I will done for today. So what I need to do, I have the rows and calls, and I'm taking the prediction dims. One thing I need to be sure is utils compare dims that the predictions and the target have the same dimensions. What it returns? It returns bool. So if not, right? If not, then panic. Incorrect dimensions, because I should have the same number of the outputs from the model and the same number of the kind of correct values for the target. So if it's not okay, then what I need to do, I have the, what is T? Okay, I am removing this, and the result should be in the size of the rows, because we'll have one-dimensional array representing all of the samples. And so what we should, what we do, we have the result, but here instead I need to calculate it for rows. So what I'm doing here, I need to declare some variable where I will be collecting all of the sums of the math poles. Then for j equals to 0, j less than calls, j plus plus, and what do we do? We have the sum, and we're adding, what is it, math power between. And what we're checking? We're checking the prediction at ij from the model minus the target value. And we should make it in the power of 2. And that will be our sum. And as the result, we need to divide sum by the number of the calls. That's basically it. Then what I can do. If you take a look at the mean square. Oh, actually I have the backward method, right? With the backward, it's actually, I think, number of the outputs. Okay, but so that's actually simpler. I just need to change target at I and j, and that's it. Okay, so we fixed the mean squared error. Then I'm doing the same for the forwards, right? The only difference is, okay, I have the utils, I check. The only difference is how I calculate this. So that will be the ABS, absolute value. And I think that's it, right? So then we need to change the backward methods. And okay, that's basically the same. We need to have the targets at I and j, and then. All right, so those two are fixed. Then there is a binary cross entropy, and I need to remember how I need to fix it. Well, first, I don't remember where it's used, because maybe it's actually okay. Binary, okay. So we clip, oh, okay. So again, we need to calculate the mean across sample losses. But that's the tricky part, right? Calculate sample-wise loss. I mean, it's actually done it here. Okay, so what I changed? That's actually, oh, sorry. That's actually should be again targets at nj targets, right? Yes, y true. I don't need this because it's already, and again, okay. But here it should be roles calls equals to prediction dimensions, right? Be roles. And okay, roles calls. Okay, let me take a look once again. So we have -1, right? Multiplied by this sum between the targets, multiplied by clipped value, and 1 minus target again, right? Multiplied by y logarithm from 1 minus y prediction. And then we create the sample losses. We sum all the things across temp, across the row, and then we calculate the mean value. Okay, so looks like it's what I need. What? What to do? Fix mean absolute error, mean square error, binary cross entropy to work with array of arrays for target data. Done. Let me check once again. Fix it. Okay, I have the categorical cross entropy backwards. Softmax. Well, softmax is a different. Okay, I actually have more. Right, I have the binary, which I think that should be the same. Let me check how long I've been recording. 20 minutes. Okay, maybe I will be able to fix one more. Okay, let's go with the binary cross entropy loss. I think that should be more or less. Wait, that's what I've been fixing, right? Oh, I forgot to fix the backward methods. Okay. Let me check. Okay, I will just calculate. Yeah, I just need to change the way it's written. We have the column right. And by the way, I have clipped the values and I use d values. Okay, I found another possible issue. So I have this one. I'm removing this. I don't need typecasting because it returns float 64. It's not the d values, it's d values clipped. And then same here. And targets at I and j. Tracks, and there is one. And again, here it's d values clipped. And okay, I will write its value what 64 outputs count and inside sample count just to read it easier. Okay. Yep. Good. I found that I didn't use the clipped one. Okay, where else I have the to-do? I have the softmax loss, but this one is cursed. And that's a whole nother story. Okay, I have the categorical cross entropy loss. And I'm checking. Okay. We have y clipped, then we do this, and we just calculate mask values only for the one hot encoded values, but I don't have one hot encoded values. Boom, boom, boom. I have the confidences, but I think this one should work because the predictions is array of arrays with the how it's called with the probabilities, and this is why we convert in. I mean, this is why we have this line. We predictions. No, wait. Yes, so for the confidences, we take in the predicted probability for the target class from targets. The thing is that they should have the same number of the predictions or number of the rows, but in my case, the target should be one, the column should be one. So if, oh, I need to check it. Calls equals to, but it's basically, okay, calls equals to target dims, and then if c is not equal to 1, it means that target does not consist from target class, should have one value for sample. But then I don't need to fix it because, well, okay, then I can write it in a way, target, that I have at I is the number of the sample and 0 is the column. In that case, and actually, or change to, or and okay, confidences, right? One hot vector check. This one is interesting. I think I need to have the same, right? But then there is a question. Okay. So it means that here I will have targets at I is 0 and hmm, there is a backward. Okay. If labels are spare, turn them into one hot vector. Okay, basically here I need to do this on hot. So if, okay, so we go over the values, labels count, where each column represents the kind of the output of the concrete class. Okay, so here it makes sense to do this. And on the line 11, we check that basically if we're on, while we're going over the d values, if we're on the column that is equal to the output class, and we take the output class value from the target, then we do the calculations. Okay, so okay, I have not now. I have the model. Okay, this is the first one. Looks fine. Main. That's what to see. Wait. Regression model. Okay, the regression model works to have the same things. All right. That's okay. Refactoring is done. I fixed it finally. I've been postponing it for a long time. The next thing I will do tomorrow is to we'll go back here and finish with this hacky solution for optimized combination of the softmax and category cross entropy loss. And so far it should be ready. Oh, well, I mean, I will test this model too, which has a lot of the layers. I will test this model too, and we will see if it works, because if it works, then I think there is nothing left for me to be able to go to the next chapter. But for now, thank you for watching, and I see you tomorrow. Bye-bye.